You ever see a drone just hanging in the air, zipping around, and wonder, how in the world is that thing doing that? It can seem like straight up magic. Well, today we're going to pop the hood and take a look at the incredible tech that gets these unmanned aerial vehicles, or UAVs, off the ground.
We're about to explore the 4 main ways a drone can push itself through the air and take flight. And you'll see, each one is built for a totally different kind of job.
Here are the big 4. You can almost think of them as having their own personalities. First up, you've got electric propulsion. This is the quiet, stealthy one, super efficient and perfect for sneaking around. Then you've got the muscle, the internal combustion engine. It's loud, yeah, but it brings the raw power you need for heavy lifting. For the long-haul missions, you have the marathon runner, gas turbine propulsion, designed to go the distance. And finally, you have the speed demon, turbojet propulsion. It's built for one thing and one thing only: pure, unadulterated speed.
Now, while those other engines are super cool, the truth is the vast majority of drones you'll ever see in your life, we're talking photography, package delivery, you name it, they're all powered by electricity. So for the rest of this explainer, we're going to zero in on that system because it really dominates the drone world.
So let's get under the hood of a typical electric drone. What are the pieces that make it all tick? You know, it's actually a pretty elegant and simple system once you see how all the parts fit together.
It's really just a beautiful 4-step journey for the energy. It all kicks off with the power supply, the battery. That battery shoots electricity to the motor, and the motor's job is simple: turn that electrical juice into a physical spin. But how fast should it spin? Well, that's where the electronic speed controller, or ESC, comes in. It's the brain of the operation, telling the motor exactly how fast to go. And finally, that spinning motor turns the propeller grabs the air, and boom, you've got lift.
So you see, everything, and I mean everything, starts and ends with that battery. It's the heart of the whole system. But that just leads to a bigger question, right? How does this little box full of chemicals actually create the electricity to make a machine fly? To figure that out, we've got to go microscopic. We're about to dive into the fundamental science that lets a small package of chemicals power everything from your phone to a high-tech drone.
Okay, so at its core, a battery is a little chemical wonder. Here's a common misconception. Batteries don't actually store electricity. Nope, they store chemical energy. And through this really clever process, they convert that stored potential into a flow of electrons, which is electricity, whenever you need it.
Check out this diagram. It makes a really complex idea super simple to understand. Basically, you've got 2 different metals. Those are the electrodes. And they're sitting in a chemical soup called an electrolyte. The chemistry just naturally makes electrons pile up on one side, and they desperately want to get to the other side. So, when you connect them with a wire, they flow. And that flow of electrons, that's electricity.
So, every battery has these 4 essential parts. You've got the anode, that's the negative side that's giving away electrons. Then you've got the cathode, the positive side that's happy to take them. The electrolyte is the chemical medium that lets charged ions flow back and forth. And finally, you have the separator, which is super important. It's a barrier that keeps the 2 sides from touching and causing a short circuit.
Okay, so this all leads to the real magic trick, right? The rechargeable part. This is obviously what makes drones practical. It's all about the difference between using power and getting it back. Let's look at the 2 modes of a drone battery: charging and discharging.
The easiest way to think about this is like a 2-way street. On the left, we're discharging. That's the natural flow. The chemical reaction is pushing electrons out to power your drone. On the right, we're charging. We're using an external power source, like from your wall outlet, to act like a pump and force all those electrons back to where they started, resetting the whole system.
So when your drone is up in the air, this is what's going down inside that battery. The chemistry is just naturally pushing billions of electrons from the negative anode through all the drone's electronics and over to the positive cathode. That organized rush of electrons is the current that powers your motors.
But when you plug that battery into charge, you're literally fighting against that natural flow. You use the higher voltage from your charger to act like a powerful pump, shoving the electrons back from the cathode to the anode, reversing the chemical reaction. And just like that, the battery is reset and ready for another flight.
All right, so we get the basic science now. But here's the thing. Not all batteries are created equal, not by a long shot. Let's take a look at the different categories out there and see why drones depend on one very specific type.
Broadly speaking, you can split all batteries into 2 big groups. First, you have primary batteries. These are your one-and-done types. Think of the AA batteries in your TV remote. Once the chemistry is used up, they're finished. Then you have secondary batteries. These are the rechargeables. The chemical reaction can be reversed, which is why we use them in things like our phones, electric cars, and of course, drones.
And inside that world of rechargeable or secondary batteries, there is a clear, undisputed champion for drones, lithium-ion, or what you'll usually see called Li-ion. This is the exact same tech that's in your laptop and your smartphone, and for some very, very good reasons.
So why is Li-ion the king? Well, it's pretty much the perfect storm of features for anything that needs to fly. First, they have a super high energy density. That means they pack a massive amount of power into a small space. They have low self-discharge, so they don't lose their charge just sitting on a shelf. They're easy to take care of. But the absolute killer feature for flight? They are incredibly lightweight for the amount of power they put out.
And there you have it. How crazy is that? We started way up high looking at 4 different kinds of engines, and we drilled all the way down to the flow of tiny little ions inside a battery that makes the whole thing possible. It's a journey from massive engineering down to microscopic chemistry.
Which leaves us with one final, really exciting question. We've seen just how essential lithium-ion batteries are for modern drones. So as scientists are in the lab right now pushing the limits with new types of batteries, what does that mean for the future of flight? Are we going to see drones that can fly for hours or even days? Or new types of aircraft we can't even imagine yet? The next great leap in aviation might just be brewing inside a chemistry lab.